Assalamualaikum everyone. In this video, you will learn about proving by mathematical induction. There are several proving techniques that we can use in this course. First one is forward-backward, construction, choose, specialization, contradiction, contrapositive, and mathematical induction. But in this session, we will discuss about the mathematical induction method. At the end of the session, you will learn about what is proving by mathematical inductions or PMI, when to use the PMI and the algorithm of this PMI.
What is PMI? The word induction comes from the word induce, which means to lead, to cause, to influence, or to persuade something to happen. There are many real-life examples which is related to the concept of induction. For example, in medicine, the administration of anesthesia follows the induction concept, where the administration of anesthesia to establish a deep anesthetic situation in a patient. In engineering, generation of an electric current in a conductor such as copper wire is also following the concept of induction. In real life, psychology of habits is highly connected to the concept of induction. For example, a person who goes to the gym, the action will lead to increased work productivity, which in return will lead to better sleep at night. The following video will demonstrate the concept of mathematical induction, which is known as dominoes effect. As we can see in this video, when the initial block tips, it will lead to the second and the consecutive blocks to tip as well.
When to use PMI? So we can use proving mathematical induction when statement B contains the universal quantifier. The statement B is in the form of for every integer n greater than or equal to n sub n, comma, something happen. This something happen is some statement P of n that depends on the integer n. Basically, there are two steps of induction. The first step is to verify that the P of the initial value or P of n sub n is true. And the second step is to use the assumption that P of n is true to prove that P of n plus 1 is also true. Let's look at our first example. The question is to show that for every integer n greater than or equal to 1, the summations of k, where k starting from 1 to n is equal to n plus 1 over 2. So how do we do about it? There are several steps to prove this statement. First, we begin by letting the given mathematical statement as Pn. Then, we need to show that for the initial value of n, which in this case n equal to 1 is true, by showing that the left hand side is equal to the right hand side of the statement. So let's see. By replacing n equal to 1, our left hand side is equal to 1 and our right hand side is also equal to 1, which means our statement is true for n equal to 1. So the following require us to assume that P of K is true, and using that to show that our P of K plus 1 is also true. As you can see, replacing K with K plus 1 to our statement changes the upper bound of our series to K plus 1 on the left hand side. Meanwhile, all K will be replaced with K plus 1 in the right hand side of the mathematical statement. We start from the left hand side, and as we can see, the summations of the K term is basically equal to our P of K in the assumption, which is K plus 1 over 2. Then, adding the last term, which is K plus 1, and simplifying it, we have shown that the left hand side of our P of K plus 1 is K plus 1, K plus 1 plus 1 over 2, which is equal to the right hand side value of our P of K plus 1. Thus, this concludes that by the principle of mathematical induction, since P1 and P of K plus 1 is true, so therefore our P of n is true for all n greater than or equal to 1. You are welcome to view related additional materials such as video, notes, and tutorial. And you are also encouraged to sit for the online assessment provided here. If you have any questions, please don't hesitate to contact us.